Hello, hi, good morning. Once again, welcome to the last class of Chemical Kinetics. Today we are successfully at the end of very first chapter from my side, that is Chemical Kinetics. And here we are going to discuss you the activation energy problems. And according to me, if they ask you the problems, definitely they will ask only this kind of the problem. Means in the previous years only the oftenly or frequently answered questions is only to calculate the activation energy. Therefore, comparing to the last class, no doubt it's also important, but almost commonly arriving problems are nothing but it is based on activation energy. Means EA, calculate the activation energy. No doubt there are some other terms are there to determine, but they are asking you only regarding the activation energy EA. Okay, so let's begin. So today also we are solving you some of the problems, that is up to 6 problems are there. We will start first one. The first problem is the decomposition of hydrogen iodide, that is Hi is splitting as hydrogen and iodine, as the rate constant of 9.5 into 10 to minus 9 per mole liter per second at 500 Kelvin. Its temperature is Kelvin 500. At that time the rate constant is 9.5, and the another rate constant is 1.10 into 10 to minus 5, and the sign it is per mole liter per second, and it is arriving at the temperature 600 Kelvin. So using these two terms and data, you should be able to calculate the activation energy. So here activation energy is nothing but EA. They have given K1 and K2. K1 is nothing but the rate constant which is they have given in the lower temperature. Lower temperature they have given, means they have given two temperatures. One is 500 Kelvin and another one is 600 Kelvin. The 500 Kelvin's rate constant is, that is K1. K2 is nothing but 600 Kelvin's rate constant. So K1, K2 they have given, and T2, T1 also they have given 600 Kelvin and 400 Kelvin. Similarly, T1, T2 is given temperature. R is the gas constant. I think R value sometimes they will give it, if they are not, means it's understood. While in the theoretical part also I have explained it, the rate constant is 8.314, and in second PUC itself you are going to get some other gas constant. It is simply a gas constant, and universal gas constant value somewhere is different. But particularly in chemical kinetics, R value will be 8.314. You should keep in your mind. So let's begin. They ask you to calculate EA. R they will give you obviously. K2, K1, T1, T2 they have given. Using these terms, you should be capable to calculate EA. So let's start. Here we no need to arrange another formula directly for EA. As it is, we have to substitute the given data, because after solving this log value, we can shift the numerical value. Don't try to rearrange EA is equal to some value. Don't rearrange the equation at initial position. Starting, no need of arranging the equation. So we will solve the first K2, K1 and T2, T1 and all, and later we will shift to calculate EA value. Okay. So let's start. Solution for first problem is, for always first time we have to write the given data, because in the annual exam they are splitting the marks for given data, formula substitution, and the final answer with assignment. Like that they are splitting the marks. That's why you have to follow these conditions. Here given data is nothing but they have given K1 value, they have given K2 value, and K1 is nothing but 9.51 into 10 raised to minus 9. 9.51 into 10 raised to minus 9. At what is that? K1 means temperature, and K1 is equal to 500 Kelvin. I have not mentioned the assignment is understood. And K2, rate constant of K2, that is they have given 1.10 into 10 raised to minus 5. 1.10 into 10 raised to minus 5. Same assignment will be same. At temperature, this temperature is taken as T2. For T1 is nothing but for K1 for the rate constant K2, the temperature is T2. It is 600 Kelvin. Most of the time it is understood that the lesser temperature is T1 and the greater temperature will be T2. Based on that, you should be capable to or differentiate K1 and K2. I hope this is clear for you. Okay. And R is equal to, even though they have not given, might be given 8.314. And here what you have to calculate is activation energy. Therefore, EA is equal to quotient mark. So this is the initial step, first step, writing the given data. And next we will move to the formula. So let's write. We know that log K2 upon K1 is equal to EA divided by 2.303 R into T2 minus T1 whole divided by K1 into T2. So we will substitute the K1, K2, T1, T2 in this formula. Therefore, log K2 is nothing but 9.5 into 10 raised to minus 9 divided by, sorry, K2 is nothing but 1.10. It is K2 is nothing but 1.10 into 10 raised to minus 5. K1 is nothing but 9.5 1 into 10 raised to minus 9 is equal to, we just put it here as it is, E divided by 2.303 as it is. R is nothing but 8.314. I will love this formula. And next one is into T2 minus T1. Here T2 is nothing but 600 minus T1 is nothing but 500 divided by 500 into 600. So first thing, once again I will tell you, if you are written formula, then you have to substitute the given data. So after substituting, what you have to do is first you substitute 1.10 divided by 9.51 by your calculator. You are going to get some value. Log of this 10 raised to minus 5, 10 raised to minus 5, and 10 raised to minus 9. Here this is the denominator, and if it move to the numerator, then minus 9 becomes plus 9. So minus 5 plus 9 is equal to, minus into plus means you have to subtract, greater number is positive, therefore the value is 10 raised to 4. 10 raised to 4. And remaining A as it is 2.303 and into 8.314. We just multiply this one. 600 minus 500 is 100. 6 5 30. 1 2 3 4 zeros. Double zeros are cancels each other, and these values are nothing but. So here I substituted the multiplication of this one here and division of 1.1 and divided by 9.5 values this one. So look here, the log of this value 0.1156 into 10 raised to 4. 10 raised to 4 is nothing but the value is in power, means 10,000 the value. By multiplying this 10,000 to this number, this point is shifting to 4 digits. After the 4 digit means 1156. After this 5 digit I am putting this point 0. If the after the point 0 is there, no need of substituting that one. If the numerical numbers are there apart from 0, we have to put the dot. If it is not there, it is understood. So I am shifting the decimal point to the right 4 terms because power is 4. Therefore, 0.1156 becomes 1156 is equal to EA divided by, here it is 1 divided by 3000. 3000 into 19.147142. The value becomes is 57,441. So the log of 1156 is 3.0625 is equal to remaining as it is EA divided by 57441. So we need EA value, therefore we will send this denominator to the left side. Therefore EA is equal to, by multiplying these two, we are going to get the final answer as 175936. 175936. We know that activation energy assigned is joule. Energy assigned is joule. But the numbers are larger one. That's why we can convert them to the kilojoule. Kilo is nothing but 1000 grams. Nothing but 1000 itself is called as kilo. If you are written up to here, there is no problem. But if you are mentioned the final expression kilo means it is better. Kilo is nothing but 10 raised to 3 is called as kilo. Means we have to remove these 3 terms. In that the point will be here. We are shifting this point to the 3 digits left side. Therefore, the point comes after, it's between 5 and 9. So 175.936 kilojoule. How I am writing means, just instead of writing the terms, I am writing the 175.936 into 1000 it is, into 1000. By multiplying this 1000, the number we are going to get the same thing. Instead of writing that long number, we are writing that in kilojoule. Kilo is nothing but 10 raised to 3. Therefore, this is the final answer. And sometimes you may get the numerical value, the last terminal may be a different based on its calculator. So if you are getting slightly different values, don't worry, but focus on the initial points. 175 is correct. And I hope this is not a very much difficulty, but even though you are having very less problems, try to solve that one. And you are having doubts, means you just go through the problem and you can text me, I will solve it. Is it clear? EA, first substitute as it is and calculate the log value, and just to send the multiply this to them, and you are going to get EA value. Okay, so we will see the next problem. And in the third problems and second and fourth and sixth, and you have to understand that because these three are the very much nearer and it's similar to the others which I am dealing. So therefore, I will shift to directly third one, and you try to understand the second one, fourth one, and sixth one. Okay. So third one, the slope of the line in the graph log k to the base 10 versus 1 by t for the reaction is, means slope they have given the answer, that is minus 5841 Kelvin. Calculate the activation energy for this reaction. Look here. So it is related to some other theory part, but it is not quite different. So log k to the base 10 and slope reciprocal of the temperature, that is 1 by t. The graph of log k versus 1 by t. When we draw a graph, we can draw any of the slope by taking 2 points. That the slope value means the graph log k versus 1 by t. We are getting some slope value. That the slope is equal to the minus EA upon 2.303 R, means log k versus 1 by t means temperature. This graph's slope is equal to the value minus EA upon 2.303 into R. So by keeping this formula, we can able to solve this problem. You should remember how we are getting this one, means it's not there in theoretically, means it's not related to any of the theoretical part, it's extended parts. So therefore, based on this data, they have given slope value. Slope is equal to slope solution, and this 5800 and how much it is? 41. 41. This is the slope value. Slope is equal to, and you need to calculate A value. A is equal to question mark and R. You are familiar 8.314. So by using the formula, slope is equal to minus A upon 2.303 R. The slope value is minus 5841 is equal to minus A upon 2.303 into R is nothing but 8.314. By multiplying these two terms and multiplied these two terms, we are going to send this to the right side, left side. Then here also minus it cancels, here minus will cancels, so minus will cancels. By multiplying these two, and we are going to get send this value to the left side, and it the denominator is moving to the numerator of left side. Therefore, the multiplied value is, so the multiplier of 2.303 into 8.314 is 19.147142, and we are sending this value to the left side. Therefore, it becomes 19.147142 into 5841 is equal to PA. The multiplier of these two are 11838. This is the EA value. So EA value, so we can say this is the joule, 11838. This is joule. If you want to convert this to the kilojoule, means we have to shift the decimals. Think that the decimal point is here. By shifting this to the 3 digits of left side, therefore EA value becomes, means point, this decimal I am sending to the 3 terms of before 3. 1, 2, 3 means 111.838 kilojoule per mole. You have to write the SI unit of activation energy. EA value is E capital and small is subscript. EA is equal to 111.838 kilojoule per mole. In the previous problem, we are not mentioned per mole, mention it without fail. EA is equal to 111.838 kilojoule per mole. I hope this is clear. Quite different problem it is. So first write it as somewhere note. After note you just draw this one, and later you begin to write the solution of this problem. Okay. The fifth one problem. In a reaction, the velocity was found to be doubled. In a reaction, the velocity was found to be doubled is nothing but the rate of the reaction is doubled, means speed of the reaction is increased. If the speed, means velocity, is doubled is nothing but rate of the concept is also doubled, means rate of the reaction is directly proportional to the speed of the reaction. Therefore, if the velocity is doubled is nothing but rate of the constant is doubled. Think that initially it is k1, and by increasing the k1 becomes 2k1. So in a reaction, the velocity was found to be doubled when temperature rises from 30 degrees Celsius to 40 degrees Celsius. Means 30 degree to it is converting as 40 degree. Calculate the activation energy. So EA you have to calculate. So here solution, the given data here. First one they have given you, calculate the activation energy. Means activation energy itself is a question here. EA is equal to question mark, and they have given the temperature T1 and T2, but they have given the temperature in the form of degree Celsius. You have to convert that into the Kelvin, because degree Celsius is not the SI unit of temperature. The SI unit of temperature is Kelvin. Therefore, degree Celsius can be converted as Kelvin by multiplying 273.15. Sometimes we are neglecting 0.15. Simply we are adding 273. So it's also no problem. So 273.15 plus 30, and this is 273.15 plus 40 degrees Celsius. This is the conversion, and they have given the initially the concentration, the velocity of the reaction is double. Double is nothing but think that the initial concentration K1, initially concentration is K1, and the final concentration K2 is double of the initial concentration, means K2 is equal to 2 K1. Using this relation, you can able to solve the EA value, means activation energy. So here 40 is nothing but 303 Kelvin, and this is 313 Kelvin. Same problem, log K2, we know that log K2 by K1 is equal to EA upon 2.303 R into T2 minus T1 divided by T1 into T2. So just substitute the given data here. Here, after writing the given data, you have to write the formula. To that formula, we are substituting the given data. Look here, log K2 is nothing but K2 is nothing but it's the price of the initial concentration. That is log K2 we are writing as 2K1. 2K1 divided by K1 as it is equal to EA. We have to calculate EA value divided by 2.303. 2.303. R is nothing but what? 8.314. I have not written in the 8.314. If the given data I have not written, sometimes if they give, if they are not given, means it's understood. The R value is always 8.314. Particularly in this chapter, you should remember, particularly in chemical kinetics, R value is 8.314. In some chapter, it may have some variation because it is universal gas constant. I said in the last class also. Once again, I am reminding you. T2 minus T1. T2 is nothing but 330 minus T1 is nothing but 303 divided by 303 into 330. Here K1 cancels, remaining is log 2 EA as it is, multiply of these two, we will write here, into 13 and 3 is nothing but 10 divided by multiply of these two is, see here, the multiply of 2.303 and into 8.314, this is the common in the main problem, that is 19.147142, and the multiple of 303 into 313 is 94,839. So here log 2 value is 0.3010, it's a constant value, is equal to EA as it is. EA into 10 is nothing but 10 EA divided by multiplying these two terms, otherwise you just keep here as it is 19.147142 into 94,839. We need to calculate EA value. Therefore, we are sending this numerator to the denominator, means it is shifting to the left side. Therefore, 0.3010 into 19.147142 into 94,839. We need EA. Therefore, it's multiplied by 10. That 10, if we send it to the left side, it becomes EA. That 10 comes below. That is the whole divided by 10. And by multiplying this of 3 terms divided by 10, you are going to get the EA value. EA is equal to 54658. 54658.46. This is joule per mole. Joule per mole. So one can be written here or whole divided by joule per mole. So here it's same thing in the last problem also. We are converting the, if the numerical value is larger one, so we can convert into the kilojoule. How means by dividing the 1000. This point is shifting to the 4 terms. So therefore 54.658 kilojoule per. So this is the final answer. I hope you are understood this one. So if you are having any doubts, you just ask me or observe it once again. This is easy problem. Solve it again and again, the same problem only. So you never feel difficulties, and we will meet in the next video by another new chapter. And if you are having any doubts, most of you ask the doubts, and still you are having any doubts, feel free to ask me theoretical or problem parts. I will solve you, and from next video onwards I will be in front of you with a new chapter. So if you are having any doubts, ask me or text me, or you can call me. Okay, so we will meet in the next video with the new chapter. Bye.